Objective 4. Describe the meaning of square root and principal square root. What numbers can you square to get 25? That is, if we square positive 5 and raise it to the second power, well, positive 5 times positive 5 gives you 25. And if we take negative 5 and we square that, so negative 5 times negative 5 gives you positive 25. We call these two numbers, 5 and negative 5, square roots of the number 25. Of the two square roots of 25, the non-negative square root, positive 5, is called the principal square root. The definition: if a is a non-negative number, then the square root of a is the non-negative number we square to get a. So we would call the square root of a the principal square root of a. So, for example, find the square root by hand if possible. The square root of 36. So what they're asking is that what number do you have to square to get 36? Well, the principal square root is the positive value of that, so we know it's 6. For part B, what do we have to square to get negative 81? Well, this is undefined because you cannot take the square root of a negative number. Let's verify that on the calculator. If I take the square root of negative 81, it gives me an error. Okay, so you can see there that we get an error. Now, what if the negative is on the outside? Well, we first need to follow order of operations. So we need to find out, okay, well, what do I have to square to get 49? Well, the answer is 7, and then we bring down the negative. Okay, in the next example, we have negative times the square root of negative 100. So again, using order of operations, we need to first find the square root of negative 100. But we found out that in part B that you cannot take the square root of a negative number because that makes that undefined. Okay, objective 5, approximate a principal square root. Recall that a rational number is a number that can be written as a fraction or in the form of a over b, where a and b are integers and b is not equal to 0. A perfect square is a number whose principal square root is rational, meaning that when you take the square root of the number, that number that you find, the result, can be written as a fraction. So for example, 16 is a perfect square, since the square root of 16 is equal to 4, and that's equal to 4 over 1. Also, 100 is a perfect square, since the square root of 100 is equal to 10, which is equal to 10 over 1. However, 7 is not a perfect square, since the square root of 7 is not a rational number. There is not an integer that you can square to get to 7. Below is a list of the first few perfect squares. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So these numbers are all considered perfect squares. Now, any square root of a number that is not a perfect square is irrational. We will use a calculator to estimate square roots that are irrational. So let's take a look at this answer here. So it says, for example, state whether the square root is rational or irrational. If the square root is rational, find the exact value. If the square root is irrational, then you estimate its value by rounding to the second decimal places. So here we have the square root of 144. We can see that 144 is a perfect square. And what number do you have to square to get 44? Well, the answer is 12, so it's considered rational. Okay, the square root of 56. Well, if we look at the number 56, it's not a perfect square. So it's going to be a number that we need to use a calculator with. So let's find the square root of 56 on our calculator, and then we get 7.483, and so on. So this number is irrational because it's not a perfect square, and there's no number that we can square to get 56. Now, if we round it to two decimal places, the approximation would then be 7.48. Next, we have the square root of 18. Now, is there a number that we can square to get 18? Well, the answer is no, because it's not a perfect square. So now let's approximate by putting it into our calculator. So we can take the square root of 18 and we get 4.2426 and so on. Rounding it to 2 decimal places, we get an approximation of 4.24, and this number is irrational. If we take a look at part D, we have the square root of 81. Well, 81 is a perfect square, and what number do we have to square to get 81? The answer is 9, so it's considered rational. So all the perfect squares that we can take the square root of are going to be considered rational. Otherwise, if it's not a perfect square, when you take the square root of that number, it's going to be irrational.